Okay, hey everybody. So this is a video over section 8.3. Sorry if you hear some nature cat going on in the background. My 3-year-old is watching some PBS. All right. So this is just a video over adding and subtracting rational expressions. I know I did part of it in class already, but I'm just going to go through the whole thing like I haven't seen it yet. All right. So first things first here. Adding and subtracting rational expressions is very similar to adding and subtracting fractions. You know, we did this whole fraction review. And hopefully we have a good understanding of how to add and subtract with just numbers, because if we add and subtract with just numbers, it's really just the same with polynomials, or rational expressions. Now, obviously, if you have common denominators, life is good, right? We got 1/5 plus 3/5 is equal to 4/5. You know, when you have common denominators like the 5, and the 5, you just add together the both numerators. So 1 plus 3 gets us the 4/5. Same thing with subtraction. You just subtract on top. 6 minus 4 is 2, so it's 2/7. So once you have common denominators, it's really quite easy. All right. So like for here, we have x plus 4 as our common denominator. Remember that it's always over x plus 4, or whatever it is, whatever the common denominator is. That does not change. It doesn't become like 2x plus 8 or anything like that. And then we just add together common parts. So x plus x is 2x. And then we have a -3 and a -2 to make a -5. And we simplify if we need to, but we don't need to here. The only other thing that's asking for is which expressions, which values of x are undefined. Remember that x plus 4 is, when x plus 4 is equal to 0, it is undefined. So we have to find out when it's not equal to 0. So we just subtract the 4 over to the other side. X cannot be equal to -4, right? So that's 2 parts of my answer there, one there and then one there. Okay, simplify and then identify when expressions are undefined. Okay, oops, excuse me. Okay, for subtraction one, look, I've got x squared plus 1 here, so that means I'm going to get something x squared plus 1 over here. Okay, we have a 3x minus 6x. Don't forget about the minus sign. If you wanted like just to distribute the negative, just to remind yourself, like make that a negative, right? 3x minus 6x is a -3x. And then we have a -4 minus a -1, so -5. Right? The only thing I could possibly do if I really wanted to is pull out a -1 on the top, but that really doesn't do anything. Makes it a plus right there. But that really doesn't, what I mean when I say it doesn't do anything, that means it doesn't reduce at all in the fraction. Okay, interesting part here, x squared plus 1 cannot be 0, right? So what values of x are undefined? Well, plus or minus I is undefined, right? Because if I square root -1 there, it gives me an I. Okay, so you know, life is good when we have, okay, so that's, I should have said not equal to, I'm sorry. So life is good when we have common denominators here. Common denominators, life is really good. So what do we need to do to get a common denominator, right? Okay, if we need to get a common denominator, we basically look at the prime factorization of the denominators. Like here, the denominator here is 2 times 3. The denominator here is 2 times 5, right? So my LCD is going to need all prime factors accounted for. I need a 2 and a 3, and also a 2 and a 5. Well, the 2's already there, so I don't need to account for it again. So it's a 2 times 3 times 5, which that means is 30, not 60 necessarily, because if I multiplied 6 times 10, it would give me 60, but I don't need the whole 60, I just need the 30. Okay, now, remember, keep it at its prime factorization here. You got to think about, okay, what does 6 have, or 6 need to get to 30? I needed the 5, that extra factor of 5. So I multiply on both numerator and denominator by that factor that's missing. Here, this was 2 times 5, so I need to get the 3 in. So multiply numerator and denominator by 3, okay? And then we would just add accordingly, okay? So what does that look like in terms of my rational expressions? Well, the first thing I need to do is reduce down any denominators. I don't necessarily need to factor down any numerators, because I'm going to have to add them together in the end anyway. So I don't need to factor them down at all. So numerator stays x minus 3. That doesn't factor anyway. The denominator factors a -4 that I had to get the +3 are x plus 4 and x minus 1 plus, and then we have, okay, 2x over x plus 4. Now let's identify our LCD. Okay, the LCD is, okay, I've got an x plus 4, x minus 1 here. Those are the prime factors of the left side. And then I've got, oh, look, it's still an x plus 4. I don't need to count for it again. It's already there in my LCD. So that means, well, that means my LCD, my least common denominator, is x plus 4, x minus 1. So I'm going to go through just like I would if it was a normal fraction, x plus 4, x minus 1. When I say normal fraction, I just mean one with just numbers in it. So x plus 4, x minus 1. Because this is what we would do if they were just numbers, right? Okay, so what does this have, or this does not have? What's missing there? Nothing. Okay, well then I don't need to do anything to the top. What's missing here? Oh, the x minus 1 is missing. So I need to multiply both numerator and denominator by x minus 1. Now, why can I do that? Because it's essentially just 1. X minus 1 over x minus 1 is essentially just 1. So that gives me, distribute in, 2x squared minus 2x. Add together, x, well, we've got a 2x squared. X and a negative 2x is a negative x, and then a negative 3. Now, I would try to factor this down to see if anything factors here, because what if this polynomial that's sitting on top here, what if that polynomial can factor and it's got an x plus 4 and x minus 1? It could cancel out in the end, right? So let's factor that down real quick. 2x squared minus x minus 3. Factors a negative 6 that had to get to negative 1, or negative 3 and 2, right? So 2x squared minus 3x plus 2x minus 3. Factor a GCF. We pull out an x to get a 2x minus 3. We pull out a plus 1 because there's no GCF. The second two terms. So it's a, 2x minus 3 there. 2x minus 3 is my first factor. And the other one is an x plus 1. Okay, so that means this will reduce, but unfortunately, reducing that down is futile because it doesn't do anything. X minus 4, x plus 4, x minus 1. It's so close, it's like, oh, I really want to cancel, but I can't. So that's my final answer there. If you had left it like this, that would have been fine in this case because, oh, weird box. It doesn't factor down, but I'd like you to factor it down in the end. Whoa, geez. Okay, now, I have not stated what x cannot be, right? Okay, so we basically just have to go back to our LCD and say this can't be 0. So that means x can't be negative 4 or x can't be 1. Okay. Ooh, man. Okay. All right, let's try another one here. All right, so again, reduce down the numerator, or reduce down the denominator as much as possible. I don't really need to touch the numerators, just the denominators. So the numerator becomes, the denominator becomes 2 quantity x minus 1. The denominator becomes 3 quantity x minus 1. And we're going to leave a 3x minus 2 up here. Okay, so my LCD, all prime factors must be accounted for. On the left side down here, I've got a 2 and an x minus 1. Here, I have a 3 and an x minus 1. So the x minus 1 is still there. I just need a 3. Okay, in other words, 6 x minus 1. Right? Okay, well that means this is going to be 6 x minus 1 plus something 6 x minus 1 equals something 6 x minus 1. Okay, what did this miss, right? The 3. And so I multiply by 3 on top and bottom, I get a 9x. Okay, what did this have? Well, it needs the 2. That gives me a 6x minus 4. Now I combine my terms. 15x minus 4. That I can't reduce, so my final answer is right here. That's a much better box. Okay, LCD can't be equal to 0. Well, 6 is equal to 0. There's no solution there. X can't be 1. X can't be 1. Okay. All right, let's keep it rolling here. Subtract now. Okay, again, reduce down the denominators. Leave the numerator, right? I could pull out a 2 in the numerator here, but I don't want to. It doesn't do anything. Okay, so the bottom becomes an x minus 3, x plus 3, minus something, x x plus 5 over x plus 3. Okay, so my LCD is x minus 3, x plus 3. The x minus 3, x plus 3 comes from here. I would add in any factors here that we're missing, but it's not missing. It's right there. All right, so we have x minus 3, x plus 3, minus something, x minus 3, x plus 3, equals something, x minus 3, x plus 3. All right, so what did this need? Well, nothing, so that stays, 2x squared minus 30. What did this need? Well, this needs the x minus 3, right? There we go. Okay, so that means I need to FOIL this. I need to FOIL the x plus 5, x minus 3. So first is an x squared. Outers would be negative 3x. Inners would be positive 5x, so plus 2x in the end. And then 5 and negative 3 make minus 15. Excuse me. All right, so 2x squared minus x squared is x squared. We've got a minus 2x. Watch out for that. That's not a plus 2x. That should be a minus 2x. 0 minus 2x. And then a negative 30 plus 15. Why plus 15? Because it's minus a negative. So negative 30 plus 15 is negative 15. All right, now I have to factor the numerator down. That becomes, I've got a negative 5 and a positive 3. And x minus 3, x plus 3. Look at that. Cancels there and there. Which leaves me with an x minus 5 over x minus 3. Okay, that's my answer. Now, I have to state what x cannot be, right? So you go back to your LCD, say that cannot be equal to 0, right? X minus 3, x plus 3 cannot be 0. So we say x can't be positive 3 or negative 3. I'll just write it like this. Okay. Right. Okay, last thing that we're going to cover here is something called a complex fraction. A complex fraction is one with basically like a fraction within a fraction, right? Some rational expressions are complex fractions. It contains one or more fractions in its numerator, its denominator, or maybe both. Like here, I've got fractions in both the numerator and the denominator here. Okay, now remember, here's the technique that I like to do. Mrs. Napoltz does a technique where she multiplies through everything by the LCD. That works too. I like to treat it as like what this is saying. I like to treat this as like remember that the fraction bar is really just a division symbol. Here's what I mean by this. You know, this looks like big and bad, but it's really not too bad, right? Okay, so what does this really equal? This really equals x plus 1 over x squared minus 1 times, actually, I'll write it out as division first. X over x minus 1, right? Well, keep, change, flip. X plus 1 over x squared minus 1 times x minus 1 over x. Okay, you follow me what I just did? I just kind of rewrote it and multiplied by the reciprocal. Now, what does that mean? Come down here. I've got an x plus 1 over x minus 1, x plus 1, right? Because that's a difference of squares, times x minus 1 over x. Cross simplify and simplify above and below. That leaves me with just a 1 over x. That's interesting. That whole thing simplified down to 1 over x. Okay. Now, I assume all expressions are undefined because this would be really funky to figure out what would be undefined. You'd have to look here to see what's undefined, here to see what's undefined, what this would equal to be undefined, because remember, that whole thing is in the denominator. And then we not only have to do that, but we have to say, well, this can't be defined either, because it ends up in the denominator. Yuck. So that's why I just say, assume all expressions are defined. Okay, let's try one more of those. Okay, so what does this equal? That equals 1 over x plus 1 over 2x divided by the whole thing, right? Divided by x plus 4 over x minus 2. Okay, now I have to get common denominators here, right? So, because it's kind of like a fraction bar is like a grouping symbol there, right? So my common denominator is a 2x. So I just multiply the top by 2 as well, because if that canceled, it'd be 1 over x again, right? So there's that, and I'll keep chain flip. X minus 2 over x plus 4. Okay, that means I've got a 3 over 2x, right? 1 plus 2 is 3. 3 over 2x times x minus 2 over x plus 4. So multiply on top, I get a 3x minus 6. Multiply on bottom, I get a 3x plus 4. And I can't do anything. Notice I cannot cross out these 3 x's. No, you can't do that, because that's just, that's not a factor. That's just what the leading coefficient is. So 3x minus 6, 3x plus 4 would be the answer. Could I factor out the 3 in the numerator? Of course, but would it do anything? No. All right, I hope we're all having a good day. I'll see you later.